Hey guys, we're back with another linear and angular velocity problem. Today the problem we're going to be looking at deals with low Earth orbiting satellites. There's a few things that the problem tells us about these satellites. The first is that they orbit 200 to 500 miles above Earth. The next is they go 17,000 miles per hour. They have to go this fast in order to stay in orbit. And lastly, that the radius of the Earth is 3,960 miles for the purpose of this problem. Part A asks us to find angular velocity, that's the small omega, looks like a W, for a satellite that is 200 miles above the Earth. So 17,000 miles per hour is going to be the linear velocity of the satellite. So we know that the satellite is traveling 17,000 miles per hour. Okay. Now, we are trying to find angular velocity, so that will be W. So that means we must know R if we're going to be able to find angular velocity. Now, it tells us that this satellite is 200 miles above Earth. However, that is not technically the radius of the satellite, because if we drew Earth here, we would have the radius of Earth extending out here. That would be 3,960 miles. Then our satellite is another 200 miles above that. Now the satellite isn't orbiting around this point, it's orbiting around the center of the Earth. So we're going to have to take our 3,960 and add 200 to that to get the radius of our satellite. So if we take 3,960 miles and add 200 to this, we'll get 4,160 miles is the radius for this satellite. So 4,160 miles. Alright, so now I know R, don't know W, I do know V, so I can solve for W. We're just using algebra at this point, so we'll divide both sides by 4,160. So divide this side by 4,160 miles. Alright, and so when we do this, when we plug it into our calculator, we'll get that the angular velocity of this satellite is going to be 4.1, and that'll be radians per hour. So the satellite's traveling 4.1 radians per hour. Now, part B says we have a satellite that's angular velocity is 4 radians per hour, so slightly less than the angular velocity of our satellite here. They want to know what is the radius of this satellite. So, similar problem. This time instead of solving for W, we'll just be solving for R. So 17,000 will stay the same. 17,000 miles per hour. This time we're looking for R, and we know W, 4 radians per hour. Okay, so this means we're just going to divide both sides by 4. So what I'll get there, 17,000 divided by 4 gives me 4,250. This would be miles equals R. Now, the question is asking us how far is the satellite above the Earth? Okay, so what we're going to have to do is take the 4,250 miles, that is our total radius, and subtract the radius of the Earth from that, so that we can actually find how high our satellite is above the Earth. So if we subtract 3,960 from 4,250, we are going to get that the satellite is 290 miles above Earth. So that's another problem dealing with linear and angular velocity, so you guys can get a little bit more practice with this. The word problems can be tricky, but the more you practice these, the better you'll get and the more comfortable you'll feel working them. So thank you guys for watching. We'll catch you next time.